Imagine a farmer, standing at the edge of her field, weighing every decision on the weather. The crops are thirsty, but a sudden hailstorm could destroy months of work in minutes. Her choices, when to irrigate, when to harvest, depend entirely on what the sky will do next. This isn't just curiosity, it's survival, and it affects all of us, from the food on our tables to the safety of our communities. For generations, we've looked to the sky for answers, creating rhymes and stories to remember the patterns. Red sky at night, sailors delight. Red sky at morning, sailors take warning. Today, the stakes are even higher. Pilots, city managers, and families all rely on accurate forecasts. Weather prediction connects us all, shaping everything from emergency response to weekend plans. A reliable forecast can mean the difference between safety and disaster, profit and loss. It helps emergency services prepare, shipping companies chart safer courses, and cities function smoothly. We are, and always have been, weather-dependent creatures. That's why improving weather prediction is one of the most important scientific challenges of our time. It's not just about umbrellas. It's about protecting lives, economies, and resources. As climate change brings more extreme events, the need for better, faster forecasts is urgent. Now, a new chapter is being written, not with ink, but with data and artificial intelligence. For decades, weather forecasting was ruled by powerful systems like the European Centre for Medium-Range Weather Forecasts (HRES) model. Built on physics and run by supercomputers, HRES was the gold standard, until now. In late 2023, Google DeepMind introduced GraphCast, an AI system that learned from decades of weather data instead of relying solely on physics equations. GraphCast recognized patterns in historical weather, predicting what comes next with remarkable accuracy. In direct tests, GraphCast outperformed HRES on over 90% of weather variables. A new AI, running on less hardware, had surpassed the world's best traditional model, a watershed moment for meteorology, but speed was just as revolutionary. Traditional models take hours to generate a 10-day forecast, while GraphCast does it in under a minute. This means forecasts can be updated more often, and more scenarios can be explored. The breakthrough isn't just about beating the old system, it's about transforming what's possible in weather prediction. Faster, more accurate forecasts mean better decisions for everyone, from emergency managers to everyday people. The future of forecasting has arrived, and it's powered by AI. We're no longer limited by the speed of supercomputers. Now we can see the future of weather in real time. To appreciate AI's leap, let's look at how weather was predicted before. Traditional numerical weather prediction, or NWP, tries to simulate the entire Earth's atmosphere using physics equations. The planet is divided into a massive 3D grid, and supercomputers calculate temperature, pressure, wind, and humidity for millions of points. These machines are enormous, expensive, and energy-hungry. Even with all that power, running a single forecast can take 6 hours or more. By the time the forecast is ready, the real weather has already changed. This lag means forecasts are always playing catch-up, especially during fast-moving storms. The atmosphere is chaotic. Tiny differences in starting conditions can lead to vastly different outcomes, the so-called butterfly effect. We can never measure the atmosphere perfectly, so uncertainty is built in. NWP models are sophisticated, but they're still just approximations of a complex reality. For decades, this was the best we could do, pushing the limits of physics and computing to glimpse the future. But the process was slow, costly, and always a step behind. That's why the arrival of AI is such a game-changer. Unlike traditional models, GraphCast learns from experience, just like a human. It's trained on over 40 years of global weather data, learning how the atmosphere changes over time. Instead of solving physics equations, it uses machine learning to spot patterns in the data. It looks at snapshots of the weather and learns how one state leads to the next, millions of times over. The graph in GraphCast refers to its view of the world, a giant mesh of over 1 million points, each holding weather data. The AI learns how changes in one spot affect its neighbors, building a global web of relationships. Once trained, GraphCast can predict the next 6 hours, then use that prediction to step forward again, building a 10-day forecast in under a minute. It's fast because it applies learned patterns, not complex equations. This shortcut is built on decades of real-world evidence. The result, forecasts that are both rapid and remarkably accurate. It's a new way of seeing the sky, one that learns from the past to predict the future, and it's changing everything about how we understand weather. The real test for any weather model is how it performs when it matters most. In September 2023, Hurricane Lee put GraphCast to the test. While traditional models disagreed on the storm's path, GraphCast accurately predicted Lee's northward curve and landfall in Nova Scotia, 3 days earlier than other models. Those extra days gave emergency managers and residents crucial time to prepare. GraphCast's early accuracy reduced uncertainty, saved resources, and likely prevented panic. This wasn't just a scientific win, it was a real-world victory for public safety. AI proved it could spot subtle clues in the atmosphere and help save lives. GraphCast isn't alone. AI weather prediction is a global race. Companies like Huawei, with Pangu Weather, and NVIDIA, with FourCastNet, are building their own fast, accurate models. Each uses different AI techniques, creating a diverse ecosystem of forecasting tools. Meteorologists now compare results from multiple models, boosting confidence when they agree and highlighting uncertainty when they don't. AI models are cheaper and faster to run, opening forecasting to smaller organizations and researchers. This democratization sparks innovation and collaboration. We're moving from a few forecasting giants to a world where many minds and machines tackle the weather together. The result? Better forecasts for everyone, everywhere. Faster, more accurate forecasts are transforming daily life. Farmers can better time planting and harvests, maximizing yield and reducing waste. Airlines use AI to plot safer, more efficient routes, saving fuel and cutting emissions. City leaders get earlier warnings for storms, floods, and heat waves, improving emergency response. Even routine tasks, like planning a barbecue or managing allergies, benefit from better forecasts. AI-powered weather intelligence gives us all more control and confidence. From global industries to personal plans, the impact is everywhere. The future of weather is smarter, safer, and more predictable. AI weather forecasting is powerful, but not perfect. These models are only as good as the data they're trained on. What happens when climate change brings unprecedented events? Traditional models can simulate new phenomena using physics, but AI relies on past patterns. There's also the black box problem. AI can't always explain its predictions. That's why scientists are working to combine AI speed with the reliability of physics-based models. Human forecasters remain essential, using their expertise to interpret data and communicate risks. The future is a partnership, AI and humans working together for better forecasts. The future of AI-powered weather forecasting is just beginning. Soon we could see hyper-local forecasts, down to your street or even your backyard. As AI models improve, reliable forecasts could extend weeks or months ahead, transforming agriculture, energy, and public health. AI will also help scientists discover new patterns in the climate system, deepening our understanding of Earth. The ultimate goal, a digital twin of the planet, simulating weather and climate in real time. This would let us test scenarios, predict impacts, and make smarter decisions for the future. AI is giving us a clearer crystal ball than ever before. The next era of weather prediction is here, and it's changing how we live, plan, and protect our world.